Okay, so a reference angle is the smallest angle that the terminal side makes with the x-axis. Okay, so looking at this first question together, sketch an 80-degree angle in standard position. Well, first, I'll just label all the axes, right? So we know we start on the positive x-axis at 0 degrees. Then up here is 90 degrees, 180 degrees, 270 degrees, and all the way around is 360 degrees. Okay, so when we're asked to draw an 80-degree angle, we know we always start on the positive x-axis. And then because it's a positive angle, we rotate counterclockwise, the opposite of a clock. Okay, so 80 is a little bit less than 90, right? So we would stop a little bit short. Okay, just a reminder, when sketching, you do need to draw the arrow showing the direction, because if you don't draw the arrow, for all I know, you think it's like this, which it is not. Okay, so again, if you don't draw the arrow, you will not get credit. Okay, so this represents 80 degrees. Okay, so now, so this is the terminal side of the angle, right? So not the starting side, not the initial side, but the terminal side. Okay, so one question I ask you is what quadrant is that terminal side? Okay, so the order of the quadrants is the same as the order that you go around the circle. You got quadrant 1, quadrant 2, quadrant 3, quadrant 4. I kind of mixed. Okay. Okay, so in this case, the 80-degree angle has its terminal side in quadrant 1. Okay, I'll go back to Roman numerals. Okay, what is the reference angle? Okay, so again, the definition is the smallest angle that the terminal side makes with the x-axis. Okay, so from that highlighted terminal angle, or sorry, terminal side, there's two different angles that will lead back to the x-axis, right? One of them is to continue forward, the other is to double back. Okay, so you want to pick the one that's smaller. Okay, so if you go forward, you have to go more than a quarter turn, right? You go this much and then a full quarter turn. On the other hand, if you double back, you go less than a quarter turn. Okay, so the reference angle would be to go backwards. Okay, so then if it was 80 degrees forward, the reference angle, the angle to the x-axis, would also be 80 degrees. Okay, so in this case, the angle and the reference angle are exactly the same. Okay, and then I ask you, without a calculator, determine if sine of 80 degrees, cosine of 80 degrees, and tangent of 80 degrees are positive or negative. Okay, so how do you do that without a calculator? Well, wherever this hits, we know that the right triangle will be formed by going straight down. So sorry, let me move the 80 a little bit. Okay, so it hits somewhere over here. Okay, so without a calculator, we don't know exactly what number this length is, but we know it's some positive number, right? Because it's going upward. And similarly for the bottom of the triangle, it's going to the right, which is a positive x value. Okay, and the hypotenuse is always positive. That part people tend to get confused on. Okay, no matter what quadrant you're in, hypotenuse is always positive 1. Okay, so sine of 80 degrees is some positive number divided by 1. Okay, so we can't get the actual number without a calculator, but we know that sine is going to be positive. Cosine, adjacent over hypotenuse, adjacent over hypotenuse. Again, positive divided by 1 would be positive. And tangent, opposite over adjacent. A positive number divided by a positive number is still positive. Okay, so let me start the next one. Sketch a 127-degree angle in standard position. So again, always start on the positive x-axis. And then 127 is past 90, but not all the way to 180. Okay, so maybe somewhere around here. And don't forget to draw your direction of rotation. Okay, so here the terminal side lies in quadrant 2. Okay, so next, the reference angle. Again, two ways to get to the x-axis. You can either continue forward or double back. So this time continuing forward is faster, right? This angle is smaller than this angle. Okay, so the reference angle will be here. It'll be the distance from the terminal side to this side of the x-axis. Okay, so you've already gone 127 degrees, but then you need to now go the rest of the way to 180. Okay, so you would just subtract 180 minus 127. You need to go 53 additional degrees. Okay, so that's the idea behind this side of the page. Okay, so I'm going to give you some time to try the rest of it out. Again, you should be able to do the whole rest of the page. Go and give it a try. Let me know if you have any questions. Okay, so negative 47 degrees. Remember, negative angles rotate the opposite direction. So positive 47 would have been like right here. So negative 47, you go an equal distance, but the other way. Okay, so negative 47 degrees would land about right here. So that's quadrant 4. The reference angle. So the reference angle, again, your two options, continue that way or double back. Here, it's much faster to double back. Okay, so that's also going to be 47 degrees. Okay, so reference angles can never be negative. So just please be aware of that. Okay, so then the triangle formed. Y is negative because it's going downward, but X is positive because it's going to the right. Okay, so sine opposite over hypotenuse would be negative. Cosine adjacent over hypotenuse will be positive. Tangent opposite divided by adjacent, negative divided by positive is negative. Okay, and then lastly, negative 200. So positive 200 is a little bit more than positive 180, which is halfway, right? So positive 200 would have gone about here. So negative 200 goes about here. Okay, so that's quadrant 2. Okay, the reference angle, how do you get to the x-axis? Again, you can either continue that direction or double back. Here, it's much faster to double back. Okay, so you're at negative 200. So if you want to think about it in reverse, here is 0. So this would be negative 90 degrees. This would be negative 180 degrees, right, if you're going this way. Okay, so how far is negative 200 from negative 180? It's 20 degrees away. Again, you always use positive reference angles. Okay, and then this triangle formed has a positive opposite side, but a negative adjacent side. Okay, so sine positive over 1 is positive. Cosine negative over 1 is negative. Tangent positive divided by negative is negative. Okay, so hopefully you saw that it's really the quadrant, right, that determines positive or negative. Like, for example, the second and third problems were both in quadrant 2. So you notice that the symbols all matched, right? Because for any point in quadrant 2, whether it's here or here or here, right, the y value is always positive. but the x value is always negative. Okay, so again, the quadrant lets you determine what, when I say sign here, I mean positive or negative, what sign each of the trig ratios is. Okay, so are there any questions on this front side? Okay. Let's turn to the back of this page then. Okay, so sorry, I added a problem afterwards that I didn't put on my screen. So let me just write it up here. Okay, so I asked you to sort of explain the relationship between the coordinates and the trig values. So we saw this last class, but we didn't really explain the reason fully, so let's do it right now. Okay, so let's just draw some random right triangle. Okay, so for unknown angles, we use the Greek letter theta. Okay, so this angle can be anything. It can be 30 degrees, 45, something random like 17 degrees. Okay, so no matter what angle it is though, we know that because this triangle is on the unit circle, the hypotenuse will always be 1. Okay, and then whatever number this side length is, that'll be the y coordinate of the point. Right, because again, this is on the coordinate plane, so whatever y distance you go upward, that's the y coordinate. And similarly, whatever this length is, that's the x coordinate. Okay, so now when you do sine of this angle theta, no matter what it is, right, sine is opposite over hypotenuse. So the opposite side is y, the hypotenuse is 1. Okay, and of course, anything divided by 1 stays the same. Okay, so that's, we saw last class the pattern that the sine of an angle is always its y coordinate, but this hopefully helps explain the reason. Okay, so similarly for cosine, cosine is adjacent over hypotenuse. So the adjacent leg is the x coordinate. And again, anything divided by 1 stays the same. Okay, so hopefully this gives an explanation for the reason that to find the cosine of an angle, you can simply look at the x coordinate where it hits the unit circle. Okay, now lastly, tangent. Okay, so tangent is opposite over adjacent. Okay, so this one is going to be y over x. Right here, the 1 is not involved, so we can't really simplify it. So you just want to remember tangent is y over x. Okay, so with that in mind, looking at, again, sorry, it's off. Question 2 for you. Okay, some angle theta has its terminal side hit the unit circle at coordinates negative radical 3/2, comma negative 1/2. Okay, so we can instantly know that the sine of this angle, even though we don't know the angle, the sine is going to be the y coordinate where it hits the unit circle. Okay, so sine is negative 1/2. Cosine, again, cosine is the x coordinate where it hits the unit circle. So that would be negative radical 3/2. Tangent is y divided by x. So this one, we got to do a little bit of calculation. Okay, instead of dividing, we can multiply by the reciprocal. The 2's cancel out. Negative times negative is positive. Okay, and then I'll just rationalize this. Multiply by radical 3 over radical 3 to get radical 3 over regular 3. Okay, and now this last part, find the angle theta that hits this point. Okay, so here it might help to draw a diagram. Of course, you could have drawn a diagram from the beginning. Okay, so I'm just going to go ahead and draw in a circle. Okay, negative radical 3 over 2 comma negative 1/2. X is negative, Y is negative. So it's somewhere in quadrant 3. Okay, and I want to know the angle theta, which hits this terminal side. Right, so I want to figure out what is this unknown angle. Okay, so the way that I would approach this, I would draw in the right triangle as usual by going vertically to the x-axis. Okay, and let's go ahead and label the sides, right? We know the x-coordinate would be this side. We know the y-coordinate would be this side. Okay, and we know for the entire unit circle, the radius, so the hypotenuse is +1. Okay, so with these sides labeled, we now just need to remember our special right triangle relationships. Okay, so first, is this the 30, 60, 90 or the 45, 45, 90? Well, the 30, 60, the 45, 45, 90 has these two sides equal in length, and that is not the case here, right? So this one's going to be 30, 60, 90. Okay, so now, is this angle the 30 or the 60? So one thing you should remember is that the smaller angle is opposite the smaller side. Okay, so out of these two sides, which one is smaller? Well, the over 2 matches. So 1 is smaller than radical 3. So this is the shorter side. So it'll be opposite the smaller angle. Okay, so out of 30 and 60, the smaller angle is 30. Okay, I mean, this one would be 60, but I'm not going to label it. Okay, so again, it might help if you redraw it off to the side. Okay, and I'm not going to worry about the positive negative right now. All right, so if I gave you this, you can see that the pattern is, okay, this is x times radical 3, this is 2x, right? One is double 1/2. Okay, and then you should remember that the smallest value x is opposite the 30 degrees. Okay, so the reference angle is 30 degrees. Questions on how we figured that out? Okay, but the actual angle theta is not 30 degrees. Okay, so think about the problem again, right? Reread the situation and see if you can tell me the actual angle theta. Okay. Anyone think they know what we need to do? All right, because it's not 30 degrees, because if I do sine of 30 degrees, right, that equals +1/2, right? But here it's supposed to equal -1/2. So I think you've got the right idea, but the reference angle for 30 degrees is 30 degrees. Again, 30 degrees is over here, right? But our angle is in quadrant 3. Okay, so I think maybe what Dimitri meant was you. Sorry, say that, Nikki. 210. And where'd you get that from? I forgot what it's called. Okay. Yeah. So you need to find the angle in quadrant 3, which has a reference angle of 30 degrees. Okay, so I think that's what both of them were saying. Okay, so this would be 180 degrees, and then you add 30 degrees more, right? So the angle in quadrant 3, which has a 30-degree reference angle, would be 210 degrees. Okay, so go ahead and try out the next three problems. Again, sorry, the numbering's different for your paper. Okay, so negative radical 2 over 2 comma positive. Okay, so let me try again. Negative radical 2 over 2 comma positive radical 2 over 2. That would go in quadrant 2 because x is negative but y is positive. Okay, so I'll go and label this side as negative radical 2 over 2, this side as positive radical 2 over 2. Okay, so I recognize that the opposite and adjacent legs are the same length. Okay, so I remember that's a 45, 45, 90. Okay, but I'm in quadrant 2, right? So the actual angle is this angle. A half circle is 180, but I stopped 45 degrees short. So that leaves 135 degrees. Okay, so for the other two problems in this section, you notice I did not ask you for the angle theta because we can't get that without a calculator because these numbers are not part of a special right triangle. So they're not patterns that we've memorized. Okay. All right, so any questions on the top half of this side? Okay, so now on the bottom half, I asked you to calculate various things. Okay, so for example, cosine 300 degrees over here. So what we learned is that, okay, you can just take the x coordinate of that point. Okay, but the problem is, right, what is the x coordinate of 300 degrees? Okay, so we want to make sure we can efficiently fill out the unit circle. Okay, so let's go over to the other handout that you picked up today. Okay, make sure you're on this side with the 8 dots. Okay, so over here, I placed 8 points. So you notice there's no grid, right? There's no markings, so you can't count the squares. But I gave you the options. I gave you the 8 coordinates, and now you need to pair them correctly. Okay, so go ahead and take a minute and see if you can correctly match each of these coordinates to the 8 points. Okay, so one thing you need to reference is how the 4 quadrants, right, they have various combos of positive x, positive y, negative y, right? So we know that in quadrant 1, x is positive and y is also positive. Okay, so the two options for quadrant 1 are 2, 6, and 6, 2, right? Both x and y have to be positive. Okay, so then to decide between them, right, if you focus on the x coordinates, the further right you go, the bigger the x value, right? So when comparing these 2 points, this one will have the 6 and this one will have the 2. And you can also do it for the y coordinates, right? You know that the higher you go, the bigger the y coordinate. Okay, so out of 2 and 6, again, the smaller point is lower. So this will have a y of 2, this will have a y of 6. Okay, and same idea for the other quadrants, right? So this one, x is negative, but y is still positive. Okay, so when we're talking about negatives, the further left, the more negative the number. So out of -2 and -6 is further left. But the y coordinates are the same, right? The higher you go, the bigger the y coordinate. Over here, both x and y are negative. Okay, so the further left again, the more negative. So add a -2 and -6. The more negative, -6 is further left. And this time y is negative. So the further down you go, the more negative. Okay, so the bigger -6 or the more -6 is lower. Okay, over here, x is positive, y is negative. Okay, so for x, the further right you go, the bigger the x value. And then for the y, the lower you go, the more negative the y value. Okay, so again, why did I have us do this? Well, just to see the relationship between the coordinates. So again, further right, bigger x. Further left, more negative x. Higher up, bigger y. Lower, more negative y. Okay, so we'll want to keep those patterns in mind. Okay, so let me show you the completed unit circle again, right? The one that we put together last class. Okay, so there are 16 points on this unit circle. Okay, that's a lot of points, right? And then each of those points has a x and y coordinate. So each point has 2 coordinates. 16 times 2, that's 32 different coordinates. Seems like a lot to memorize. But if you look at the actual values, they repeat, right? So like the 1/2 shows up over and over, right? 1/2, 1/2. Okay, -1/2, but it's the same, right? 1/2. Okay, and same thing, you can see radical 2/2 a bunch of times. You can see radical 3/2 a bunch of times, and so on. Okay, so there's actually only 5 different values on the unit circle. Okay, so we can definitely memorize those, and even more conveniently, they follow a nice pattern. Okay, so let's just focus on the y coordinates in quadrant 1. Okay, so the smallest y coordinate is 0. The second smallest is 1/2. Next is radical 2/2. Next is radical 3/2. And then next is 1/2. Okay, so again, these 5 numbers and their negatives are the only coordinates on the entire circle. Okay, it's all some combo of this. Okay, and these numbers are pretty easy to remember, right? These numbers just count up one by one. Okay, if you really want, you can think of 1 as square root 1 to even fit the pattern better. Okay, but yeah, these are the only 5 values on the whole circle. Okay, and then combining this with what we said about how higher up means bigger y, lower means more negative y, further right, bigger x, further left, more negative x. We can really just fill out the coordinates very easily. Wrong one. Okay, so let's look at this unit circle now. Again, when we first filled this out, we did a very long process of, okay, here's the triangle, right? Let's do the special right triangles and so on. Okay, but now let's think about this a different way. Okay, so I'm going to fill out the y coordinates first. Okay, so just the y coordinates. Okay, so remember what we said on the other page. Okay, we know the x-axis is a y coordinate of 0. You haven't gone anywhere. Okay, so out of these 5 points, the next y value up, right, the next lowest point. Okay, so that'll be the 1/2. Okay, then slightly bigger than 1/2 is radical 2/2. Slightly bigger than that is radical 3/2. And the biggest is 1/2. Okay, so again, if you look at the points, it should make sense. The y value keeps getting bigger and bigger, right? So the y coordinates also slowly get bigger and bigger. Okay, and then now over here, now you're going downward, right? As you go down to this point. Or you can use reflection, right? These 2 points have the same y value, but I'll just count downward. Okay, so this point is a little bit below 1. Okay, so radical 3/2. This point is a little bit below radical 3/2, so radical 2/2. This point's a little bit below radical 2 over 2, so 1/2. And this point's on the x-axis, so y is 0. Okay, so now for the negatives, again, the lower you go, the more negative. Okay, so below 0 would be negative 1/2. The next point is a little bit lower, so a little bit more negative. So negative radical 2 over 2. Next, even more negative radical 3 over 2. Here it's as low as you can go, negative 1. Okay, and then over on quadrant 4, now you're sort of bouncing back up to 0. Okay, so this point is a little bit above negative 1, so negative radical 3 over 2. A little bit above negative radical 3 over 2 is negative radical 2 over 2. And then here is 1/2, excuse me, negative 1/2. Okay, so again, all these y coordinates I just filled in by like following the pattern, right? Y gets bigger, y gets smaller, y gets more negative, y gets less negative. Okay, so the x coordinates we can do basically the same way. So I'll start over here, right? So this x coordinate is a full unit to the right. Okay, this x coordinate is a little bit less than positive 1. Okay, so radical 3 over 2. This x coordinate's a little bit less than positive radical 3 over 2, so it'll be radical 2 over 2. This point's a little bit less than radical 2 over 2, so it'll be 1/2. And this point's on the y-axis, so it's 0. Okay, so over here, now we're in the negatives. Okay, so the smallest negative would be negative 1/2. The next point's even further left, so it gets more negative, so negative radical 2 over 2. The next point is even further left, so negative radical 3 over 2. And then here, negative 1. Okay, here you're going back towards 0, or again, you can use reflection. Okay, so a little bit bigger than negative 1 is negative radical 3 over 2, and so on. Negative radical 2 over 2, negative 1/2. This point's on the y-axis, so it's 0. And here, the x coordinates are getting bigger and bigger as you go. Okay, so a little bit bigger than 0 is 1/2. A little bit bigger than that is radical 2 over 2. A little bit bigger than that is radical 3 over 2. Okay, so again, what we're trying to do here is see patterns that will allow us to quickly draw our own unit circle. Okay, because on the test, I'm not going to give you a unit circle, but I'll give you blank space where you could draw your own, right? And if we can fill out the unit circle, we can quickly do sine, cosine, and tangent by just looking at the x and y coordinates. Okay, so those are the coordinates. Now we can do the angles. Okay, so you can do this in various ways, but I'll start by doing jumps of 45 degrees. Okay, so we know 0 degrees is to the right. So we know that straight up is 90 degrees. Okay, and half of that is 45 degrees. Okay, so every jump of this size is worth 45 degrees. Okay, so we're basically doing every other angle, right? We're skipping one angle in between. Okay, so next over here, 90 plus another 45 would be 135, plus another 45 is 180, plus another 45 is 225, plus another 45 is 270, plus another 45 is 315, plus another 45 is 360. Okay, and if you want, you can do the radians, or you can do the rest of the degrees first, doesn't really matter. Let's do the radians. Okay, so I've told you a few times, if you can just remember that a full circle of 360 degrees is 2 pi radians, you can figure everything else out from that. Okay, so we want to get down to 45 degrees. We can start by dividing by 2 to get to 180 degrees is pi. Divide by 2 again. 90 degrees is pi over 2. Divide by 2 one more time. Okay, so every 45 degrees is worth pi over 4. Okay, so with that, we can quickly fill out all of these radians. Okay, so 0 degrees is, of course, 0. We just calculated that 45 degrees is pi over 4. Okay, so just to make things really clear, I'm going to call it 1 pi over 4 for now. Right, so this much of the circle is 1 pi over 4. So when you add on another 45 degrees, now you have 2 slices, each worth pi over 4. So this would be 2 pi over 4. Okay, so yes, that's not reduced yet. I'll do that later. Okay, but now 135 degrees, that's 3 slices, all worth pi over 4, right? So 135 is 3 pi over 4. 180 is 4 slices of pi over 4, so that's 4 pi over 4. Okay, so you can basically see the numerator is just going up by 1 every time, right? Okay, so next up will be 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, so that's all the multiples of 45 degrees. And now we should remember the other special angle is the 30, 60, 90. Okay, so 30 degrees. No, whatever. I guess the degree symbol is already there, sorry. Okay, so 30 degrees. You can go back to the fact that 90 degrees was pi over 2. So divide both sides by 3. So 30 degrees is pi over 6. I'll just say 1 pi over 6 for now. Okay, so let's do the degrees first. Okay, so you're just counting by 30s. 30, 60, 90 is already there. 120, 150, 180 is already there. 210, 240, 270 is already there. 300, 330, 360 is already there. Okay, and then now we can do the radians based on the fact that every 30 degrees is another pi over 6. Okay, so again, this much of the circle is pi over 6. So if you add another 30 degrees, you have 2 sections, each worth pi over 6. So 2 pi over 6. 90 would be 3 sections of 30 degrees, so it'd be 3 pi over 6. Okay, so we already know what it is, but I'll just write it in so I don't lose track. Okay, so then 120 is 4 pi over 6. 150 is 5 pi over 6. 180 is 6 pi over 6. 210 is 7 pi over 6. 240 is 8 pi over 6. 270 is 9 pi over 6. 300, 10 pi over 6. 330, 11 pi over 6. And I guess 360 would be 12 pi over 6. Okay, so, the entire unit circle is now filled out. I'll just go back through and reduce the radians. Right, 1 pi over 6 is just pi over 6. 1 pi over 4 is pi over 4. 2 pi over 6 can reduce to pi over 3. 2 pi over 4 and 3 pi over 6 both reduce to pi over 2. 4 pi over 6 is 2 pi over 3. 3 pi over 6 is already simplified. 5 pi over 6 is already simplified. 4 pi over 4 or 6 pi over 6, both of those reduce to just pi. 7 pi over 6 is already simplified, so is 5 pi over 4. 8 pi over 6 could be 4 pi over 3. 6 pi over 4 and 9 pi over 6 both reduce to 3 pi over 2. 10 pi over 6 can be 5 pi over 3. 7 pi over 6, sorry, 7 pi over 4 is already reduced. 11 pi over 6 is already reduced. 12 pi over 6 reduces to 2 pi. Okay, so my strong recommendation would be on the day of the test, first thing, draw and label a unit circle. Okay, because now if I ask you what is cosine of 120 degrees, you just look here, you look at the x coordinate, and you know that cosine of 120 degrees is negative 1/2, right? Or if I ask you what is sine of 3 pi over 2, you look at 3 pi over 2, you look at the y coordinate, and you instantly know sine of 3 pi over 2 is negative 1. Okay, so again, if you can quickly fill out the unit circle, you can quickly answer all of the sine, cosine, tangent questions. Okay, so I gave you a blank one on the back for you to practice. Okay, so again, just use the patterns we learned. Okay, so, I mean, I'm not gonna do it because I don't want you to copy, right? I want you to try it on your own. You shouldn't have to draw a single special right triangle. You should just use the patterns to fully fill out the circle. Okay, so if you get stuck for whatever reason on the day of the test, you can always go back to drawing the special right triangles. But if you can understand the pattern of the unit circle, it'll be a lot more efficient. Okay, so why don't you go ahead and see if you can fill this out.